Good day. So today, I'm going to discuss pseudocode. So, let's dive in and start programs together.
What is pseudocode?
A method that allows a programmer to represent the algorithm in a more programming-related way. Pseudocode is a way of planning out how a program will work using simple, human-readable language. It's like a rough draft of your code, written in a way that's easy for anyone to understand. Instead of using the exact syntax of a specific programming language, pseudocode focuses on describing the logic and steps of a program in plain words. It helps programmers map out their ideas before diving into writing actual code, making the development process smoother and less error-prone. Pseudocodes are also called false code because it tends to look like programming language, but can still be understood by a person that has little understanding in programming.
Why pseudocode is important?
Pseudocode is important because it 1. Helps clarify complex problems. 2. Facilitates planning and design. 3. Is language independent. 4. Aids in debugging and troubleshooting. 5. Serves as a valuable teaching and learning tool. Pseudocode plays a crucial role in the software development process by fostering clear communication, aiding in problem solving, and facilitating efficient program development.
Pseudocode do's and don'ts. DOS.
1. Use clear and descriptive language. Make sure your pseudocode is easy to understand by using clear and descriptive language to explain each step. 2. Follow a consistent format. Maintain consistency in your pseudocode formatting, such as indentation and naming conventions, to make it easier to read and follow. 3. Break down tasks into smaller steps. Divide complex tasks into smaller, more manageable steps to simplify the problem-solving process. 4. Comment your pseudocode. Add comments to explain your thought process or any important details that might not be immediately obvious from the code itself. 5. Test your pseudocode. Just like with actual code, it's important to test your pseudocode to ensure that it accurately represents the logic of your program.
Don'ts.
1. Get too detailed. Avoid getting too bogged down in the specifics of syntax or implementation details of a particular programming language. Pseudocode should focus on the logic and algorithmic aspects of the problem. 2. Assume prior knowledge. Remember that pseudocode should be accessible to anyone, regardless of their programming background. Avoid assuming that the reader has prior knowledge of specific programming concepts or languages. 3. Use ambiguous language. Be clear and precise in your pseudocode descriptions to avoid ambiguity or confusion about what each step is supposed to accomplish. 4. Forget to revise and refine. Just like with any form of writing, it's important to revise and refine your pseudocode to ensure clarity and accuracy. Don't be afraid to make changes as needed. 5. Rush through it. Take your time when writing pseudocode to thoroughly plan out the logic and structure of your program. Rushing through this step can lead to errors and inefficiencies later on.
Example of pseudocode.
This pseudocode outlines a simple program to calculate and display the sum of two numbers inputted by the user. Let's break it down step by step. Step 1. Initialization. Let num1 equals 0, num2 equals 0, and sum equals 0. This initializes three variables num1, num2, and sum2 0. These variables will be used to store the numbers inputted by the user and the sum of those numbers, respectively. Step 2. Input. Input num1 and num2. This prompts the user to input two numbers, which are then stored in the variables num1 and num2. Step 3. Calculation. Sum equals num1 plus num2. This calculates the sum of the two numbers inputted by the user and stores the result in the variable sum. Step 4. Output. Finally, this line outputs the value of the variable sum, which is the sum of the two numbers inputted by the user.
Problem 2.
Step 1. Initialization. You start by initializing variables num1, num2, sum, and avi2 0. This is good practice to ensure that the variables have initial values before performing any operations. Step 2. Input. You prompt the user to input two numbers, num1 and num2. This allows the program to receive input from the user. Step 3. Calculation. You calculate the sum of num1 and num2 and store the result in the variable sum. This step adds the two inputted numbers together. Step 4. Average calculation. You then calculate the average by dividing the sum by 2 and store the result in the variable avenue. This step finds the average of the two inputted numbers. Step 5. Output. Finally, you output the calculated average. This allows the user to see the result of the calculation.
That's all for today. Stay curious, stay passionate, and most importantly, keep creating. Thank you for joining me on this learning adventure.